Now, before we dive into horizontal formatting, let's also talk about this reading flow again. Here's another example. It's a JavaScript file where I call a start function, which then is defined right below it so that we can immediately see it. And that calls a next function, which is defined right below, and the same is true for the last function. Now, if I would execute this file, it would work and I would log all these log messages. JavaScript is a language which supports this syntax. We can call a function before it was defined, because when JavaScript executes, it automatically pulls all the functions in front of the other code, so to say. On the other hand, there are other languages like Python where this is different. Here, if we would call start in line 2, it wouldn't work. This code would fail if we tried to execute it, because in Python, we can't execute a function before it was defined. It will not magically be pulled on top of the file as it was the case with JavaScript. So executing start in line 2 wouldn't work. However, executing it in line 11 here in this example also wouldn't work. Yes, start would be defined, but in start I call next, and next at this point of time, when code execution reaches line 11, is still unknown. Hence, the only place where we can call start here is after all these functions have been defined, so that they can call each other successfully. So here it's really just about when we start that function execution, and then Python simply requires that it saw every function which is called by some other place in the code before it's being called. And therefore, of course, again, you have to keep such language-specific rules and restrictions in mind when it comes to ordering and executing your functions. Now let's move on to horizontal formatting. With horizontal formatting, we are talking about a single line of code, and that these lines of code should be readable without horizontal scrolling. So we should simply avoid very long, unreadable sentences. And that all starts with indentation. We should use indentation even if it's not required technically. Now here is an extreme example. This again is the disk storage class from before, with the same code as before, but I changed the constructor. I removed all indentation and instead I put all the code in one line. It looks like this. It's a very long line of code and we have to scroll horizontally in order to read it. This code would execute. This is technically valid JavaScript code, but of course it's not readable at all. Hence, we should use multiple lines and also indentation to make it readable. Because like this, it's perfectly readable. If we just had multiple lines, but no indentation at all, and if it looked like this, therefore, it would be readable, but especially for longer functions, it's not necessarily immediately obvious that this code all belongs in one and the same function. So using multiple shorter lines and using indentation helps a lot with code readability and understandability. Now, in addition to using indentation, you should also break long statements into multiple shorter ones. And with that, I don't just mean the extreme example I showed you a minute ago. For example, consider line 19 here. I changed this line to be a bit longer, because I'm not referring to this storage path property of the class anymore, which holds the storage path, but I'm creating the path in line instead. And therefore we have a rather long line here. In such cases, it would be better to extract this code into a separate variable or constant, like this for example, and then use this variable or constant. Now it's way more readable, even though it's the same code as before. But we simply split this long line into multiple lines. Now last but not least, when it comes to horizontal formatting, you should also use clear and descriptive, but not unreadably long names. Names of variables and properties and methods can be a bit longer. This is totally fine. They can consist of multiple words. But consider this extreme example. I now renamed this constant to be very descriptive. It's the storage path for storing images in a temporary folder for the year 2020. Now this is a very descriptive name, but it doesn't help with readability. It's simply too long. It hides the rest of the line, which would actually be more explanatory than the long name, because if we would see this code immediately, it would be pretty clear that we are creating an images folder in some temp folder, which is somehow related to the year 2020. This would be much clearer than if we have to read this long name. In addition, this long name does not just impact line 19, but also line 20, where we use this long name. This line now also is partially hidden and requires some scrolling. Of course, always depending on your zoom level, but still, it's a way too long line, and hence here, the older name was definitely better and helped with readability way more. Now we saw all the rules, we had a look at all the rules, and I showed you a couple of examples. Now it's time for your challenge. So attached you find the challenge py file, it's therefore written in Python. And this file has some code. You can execute it, though I will say it will fail. You can fix it, and you'll find ideas on how to fix it in the code file. But the main priority is not that you fix this file, that you can execute it, but that you fix the comments and the formatting in the file. Not everything is wrong. Indeed, it isn't too bad, but there are a couple of things which can be improved. And I want you to go through this file, have a look at all the different comments and the formatting and the code you see here, and see how you could improve it. And then, of course, compare your solution to mine so that you also see how I transformed this file. So here's my approach to refactoring and to improving this file. And I want to start with the comments. We got a legal comment right here at the start, and as you learned, legal comments are alright if we need to add them. Obviously here I personally don't need to add it, but let's assume I am in an organization where I am required to do that, then it's of course fine to keep this around. Not fine, however, are these markers here, these dividers. Yes, these are the imports, but guess what? I can tell that they are by the fact that we have the import keyword here. And that this here is the main code, well, obviously it is. It is the only remaining code in the file. So we should remove these dividers or these markers here. Now regarding this comment, this is not a documentation comment, not a valid documentation comment as it should be written in Python. There you would use a special syntax with triple quotes, but that's just a Python thing. But we actually don't even need it here, because this comment doesn't make any sense. It's a class which allows us to create an instance of this class. Well, that is what classes typically do, so this is a redundant comment, and hence I will also remove it. Now, further down, I got 3 other comments. For example, that create directory must be called before a file is inserted. This, by the way, is the reason why executing this file would fail. You need to call log storage create directory before you call insert file. But I will remove this for now. We got a warning here, and we learned that warnings can make sense. However, we actually got this warning twice, here and then here. And if we add this warning, I would argue it makes sense in the place where things can fail. So in this case, insert file. It's good to know that we should call create directory before we insert a file, but what does this annotation add if it is next to create directory? This is not what will fail after all. Hence, I will remove this comment and leave this warning, though of course I want to emphasize that the better way of dealing with this would be to properly handle the scenario that a directory does not exist yet. So for example, to check for its existence and create it if it's missing and only continue if it exists. Nonetheless, if that's not the case, we may keep such a warning comment around, though of course it is also worth knowing that this comment can only be seen if we dive into this code base, not if we just call insert file. Nonetheless, if we call that and it fails and we then dive into the code base, this warning comment might help us with identifying the problem a bit quicker. Now this last comment here is a to-do comment, and as I said, adding proper error handling definitely is a good idea here. You should just do it instead of mentioning that you should do it, but mentioning it at least is a good step in the right direction, so I will leave it here. And that's it for comments. Now let's talk about formatting. The good thing is we got some vertical spacing here. So we got the imports, then we got this class, we got spacing between all these methods, and that's all good. And we also have spacing down there. So that all doesn't look too bad, though we could also remove the spacing down there and argue that the log storage here is created, and then we operate on this created log storage. So we could also keep these two lines together. In the JavaScript example from before, that was not the case. There we had some spacing between the creation of the storages and the file insertion, but I primarily added this because I also have this set timeout function in between. If that would not be there, an argument could be made that these lines should be right after these lines. Ultimately, that also comes down to your own preference and to what you think is easier to read. Here you can go for either of the two approaches, and hence I will remove the vertical spacing, though keeping it also would be absolutely fine. If we have a look at the methods, all the spacing looks good to me, at least the vertical one. But what about horizontal spacing? We got no super long lines here, and yet I see some small improvement potentials. For example, here. This is not too long, but it could grow over time. Here we are constructing a file path in the end, and hence what we could do is we could extract it from here and simply add a new file path variable in which we then store this derived file path, and then we use this variable here. This would make this line even shorter and even a bit easier to read. So I personally am a fan of doing that. We could do something similar here for this if statement and extract this, for example, into a separate variable. But I think here it is still fine to leave it like this. But if you extracted it, that is definitely also fine. Now, last but not least, to fix this file, we can also call log storage create directory before we insert a file. And if we do that, then I am indeed a fan of reintroducing the vertical spacing here, because now we first create the storage, and then we have operations on that created storage. So you could argue that these are two different kinds of code, two different operations. So re-adding a vertical space here could be fine then. And that is it. There wasn't too much to fix, but I hope it's clear to which aspects you should pay close attention and how proper formatting and good comments can help with keeping your code readable and maintainable. By now, in this course, we learned how to name things properly and to not overuse comments. We haven't worked too much on the actual code which we write, except for the names we assign to things. Now, therefore, in this course section, we are going to take a closer look at functions, because functions ultimately are where we write the majority of our code. Functions or methods. And in this course section, you will learn how to write clean functions. And we'll have a look at every aspect of functions. We'll have a look at the parameters, the arguments you use in functions, and how to be clean there. And of course, we're going to have a look at the function body, and we're going to talk about the length of functions, abstraction levels, and how to properly split one function into multiple functions to increase readability. And as always, we're going to do this with a bunch of examples, demos, and also a challenge for you. So let's dive in. In order to write clean code in functions, it is important that we reflect on what makes up a function. And for that, we should probably look at a function. For example, this dummy example add function here. And just as a side note, when I say function, and what I show throughout this module will also always apply to methods, since methods are really just functions inside of an object. So this is a function or method, and of course we cannot just define this function and write the code for this function, we can also call this function, which could look something like this. And when we talk about clean code, both parts should be clean. Calling the function should be readable and also easy for us as a developer. If we are calling a function, we want to have an easy time doing so. For example, the argument order should be clear. And of course, working with the function, writing code in an existing function, maintaining existing functions should also be easy. So the function body, the definition of a function, should also be readable. So therefore, it's the number and order of arguments which matters to us, because that defines how easy and readable it is to call a function. And it's the length of the function body, the amount of code we have inside of a function, which matters. And in this section, we are going to have a look at both aspects. Now, let's start with the left side here, with calling a function and with passing values for function parameters. And here, for writing clean code and for being able to call functions in a clean and understandable way, there is one simple rule. You should minimize the number of parameters your functions use. Because the more parameters a function uses, the harder it gets to call them. And harder here really means that it's harder to memorize which value should be passed as which argument, so the order of arguments can be confusing. And if you have to pass in a lot of arguments, it also simply is a lot of code to write, and ultimately that all leads to more code you have to read, more things you have to keep in mind. We can probably all agree that calling a function or method with no parameters is very simple. If we, for example, have a user object and on that user object we have a save method, then this is very easy to call and to read. We don't have to pass in multiple values and remember the order of arguments. We don't have to do anything of that. We have one function call with no parameters. This, therefore, is very easy to understand. So it's easy to understand and easy to call. And therefore, this is the best possible way of calling a function, though of course I will say right away, this is not always the way you can do it. There are of course functions or methods which do require parameters. You can't refactor every function to take no parameters. That will just not be an option. Nonetheless, sometimes you can achieve this, and if you can, this therefore is the best possible option when it comes to ease of calling and to understanding this code. Still very good is if you need one parameter, one argument. For example, if you had a log function which takes the message as the one argument it wants. This is still very easy to understand and still very easy to call. You have to pass in one value, there is no order which you have to memorize, and if you read this code, it's crystal clear what it does. So this is still a very good option you can use. Now it already becomes a bit more tricky if you have two arguments, two parameters which need to be passed in. For example, if we have a point object which we can instantiate by calling its constructor, which this code could do, where we then pass in two arguments, let's say the x and y coordinate of that point. This is still okay to understand because it is kind of common sense that probably the x value is the first argument and the y value is the second argument, but still there is some ordering which you need to keep in mind. The order could be switched and therefore this is acceptable to call, but you might have to think about it for a second to quickly verify that the first value really is the x value and the second value is the y value. So therefore you should use this approach or write functions with more than one argument with caution. In some cases, like here for a point, it is still absolutely fine because it is quite obvious that the first value will be the x value and the second value will be the y value. But for other functions, this might not be as clear. And then it immediately becomes harder to call them because you have to think about the order of arguments. And reading that code, therefore, also could become harder because it's not immediately obvious which argument fulfills which purpose. Now, if we have even more arguments, let's say free arguments, then we reach the point where it's very hard to justify why we need that many arguments. For example, if we have a calc function which calculates something, we might take in the two numbers which we want to use in the calculation, and then we have a third parameter which defines which kind of calculation we want to perform. And this is challenging to understand and challenging to call. If we read this, it is still okay if we have add as a type, but if we have subtract, it's already not 100% clear which number gets subtracted from which other number. But especially when we call this, it's also hard to understand because the order is totally not obvious. We will probably need to dive into the code or use some IDE features to understand which argument should go where. For example, the type of calculation, add in this example, could also be the first argument. Common sense doesn't tell us whether it should be the last or the first argument because this is not a common function, not a common thing, unlike the point. So therefore, you want to avoid functions like this if possible. There can always be scenarios where you need a function like this, but you will probably not have them as often as the other scenarios on the left here for non-1 and 2 arguments. Now, any functions with more than 3 arguments should absolutely be avoided. For example, if you had a quartz function which takes 4 values, this would be very difficult to understand and to read, and very difficult to call. It's not obvious at all which value describes which coordinate or what this function really does or wants. So you really always want to avoid having functions with more than 3 arguments. Nonetheless, I could imagine that you now automatically have a couple of examples in mind where you think, well, but I need more than 2 pieces of data or more than 3 pieces of data. So let's now have a look at a couple of examples and a couple of solutions for functions which need more than 3 pieces of data. Now here are a couple of examples. And let's start with this example where I have a save user function which takes an email and a password, so 2 parameters, and where we then create a user object on the fly. This is all written in JavaScript, by the way. And in this object, I save the email and the password. I also add a randomly generated new ID, which is not a perfect unique ID, by the way, but good enough for this example. And then we reach out to some database, as it seems. We could have also named this database, of course, and insert this user into a user's table or collection. Now, don't get me wrong, this function is absolutely not horrible, and if you have code like this, it's not the end of the world. Still, if you call this function, it would look something like this, and you probably would have to take a closer look at the function to understand that it wants an email address and a password, and that the email should be the first and the password should be the second argument. Again, not the end of the world, and definitely also not totally unexpected. Still, when we write code like this, we might be able to come up with a better solution. For example, we could come up with a function like this, which only takes 1 argument, which is the already finished user. So we would outsource this task of creating the user out of this function into another place in code. So obviously this only works if we construct a user ahead of time, but then we have a simpler save user function, which ultimately, of course, also is very easy to call. Still, it takes 1 argument, but now I would say it's easier to understand and call, and it doesn't leave us guessing whether email or password should be first and which kind of values this function might want. Now, an even better solution could be this one here. Here we have a class user, which acts as a blueprint for new user objects, which then has a save method which can be called without any arguments. Therefore, user.save is very easy to read and very clear and understandable. And instead, we now outsourced the problem of passing in values for the email address and the password to the user constructor function. And there you could argue it's a bit more expected and obvious than on a save user function. As I mentioned, that also wasn't horrible, but this code might make even more sense and might be even easier to understand. And therefore, this acts as an example of how you could transform code to be easier to understand and to not use any arguments on certain parts of your code where arguments might not be obvious and the order could be unclear. I also got one other example of a function that takes no arguments, and that would be this one here. Let's say we have a isLoggedIn state which we manage somewhere, and then we have a function which just changes that state. Therefore, this function does something, but it simply needs no arguments for that. It just inverts this isLoggedIn state all the time. So that would be another example of a function without any arguments, because in this case it doesn't need any. So these are some examples, and again I want to emphasize that this original solution still isn't horrible, but maybe the other solutions we derived make more sense or improve readability even more. Now let's next have a look at a couple of examples for one-argument functions. For example, here I have a log function which simply wraps the built-in console log method. Now we can argue whether such a function makes too much sense, but we could be doing that if we want the option of quickly swapping console log for some other outputting or logging mechanism. Then having our own logging function, which we use throughout our program, could make sense, because if we ever switch from console log to some other mechanism, we only need to make that switch in one place instead of in multiple places. And then we have a function where it makes a lot of sense that we need one argument and just one argument, and that would be the message which should be logged. Now we could also come up with a way of writing this such that no arguments are needed, again by creating a class which takes the message in the constructor and then has a no parameter log method, but I'm not too sure whether this really is an improvement. It's a lot of extra code, and we just replace a function where it was totally obvious that we might have a parameter, and where the kind and value of that parameter also is no surprise at all. So here I'm absolutely not a fan of changing this just for the sake of changing it. Instead, I think the original example with one argument here makes a lot of sense and is absolutely something we can keep around. Now here are more functions where one argument makes a lot of sense and is totally obvious. For example, this square function, which simply squares a number and therefore takes that number as a single parameter. Or the email is valid function, which takes the email address which should be validated as an input. These are all examples for functions which we can leave like that, and where having one argument is totally fine, obvious, easy to read, and easy to understand. Now what about functions that take two arguments? For example, take this login function here. It takes an email and a password, and then internally it might be doing whatever logic is required to log a user in, to create a session for the user, for example. This again is something which makes sense and which is expected. Here we have two parameters, but the order is not surprising, because in most forms we also have the email field first and the password field second. So this order of arguments makes sense. And calling this function is very readable. It's immediately obvious what this function does, and that we have an email address and a password as expected parameters. So this could be an example for a two-argument function, which is no problem at all. Another example would be this point class, which we instantiate by using the point constructor. We take two arguments here, the x and the y coordinate, and this again is really just common sense. It is expected that the x argument is the first argument and the y value is the second parameter, and therefore this is easy to understand, easy to read, and does nothing unexpected. We don't need to think a lot about calling this constructor function here because it is very obvious what it does and what these values will be. So, as you can probably tell by now, it is about minimizing the number of parameters, but it's simply also about how readable and how easy to understand a function is. If it's obvious which parameters it needs and in which order these parameters need to be provided, like in this login or point example, then it's absolutely fine to use two parameters. You don't need to come up with a way of reducing the number of parameters. Because after all, you should always keep in mind that writing clean code is about writing readable and meaningful code and about reducing the cognitive load. So if we have no cognitive load because it's clear and easy to grasp what a function does and how we should call it, then of course there is no need to rewrite it. And that is an important difference between the examples I showed you thus far and this example here. Here we got a log function which actually takes two arguments. And if you just have a look at the way we call this function, it's totally not obvious how we should call it, what this second argument is about, and which order these arguments should have. It's obvious that we have a message, but what does false mean here? We need help from the IDE to get some extra insight, but ultimately we probably need to dive into the code to fully understand what this actually does, and to understand that isError is an extra flag which controls how the message is being output. And you want to avoid such Boolean flags in general, but in addition, this is also a good example for a two-argument function which would better be written in a different way, or which would better be refactored. For example, here, a better solution could be to split this one function into two functions where one function is dedicated to normal messages and one function focuses on errors. That way we have two functions with one argument each, which then again are way easier to call and understand. And that is what clean code is all about. Questioning the code you have and trying to always improve it such that it's more readable, easier to understand, and requires less thinking and reasoning about the code.